Hi, everyone, and welcome back to another Planetarium show. My name is Jessica. I am the director of the Planetarium, and with me tonight is one of our students who might be a familiar face to you, but I'm still going to let him introduce himself.
Hi, I'm Eli. I'm a physics and astronomy student at UMD.
So, tonight we are going to be taking a deep dive exploration into the planet Mars. Part of our excitement for this is because of the recent Perseverance landing and all of the cool stuff coming out of that. But also, frankly, Mars is just a really awesome planet. And we think, I will say I, because I'm the one who pitched this idea, thought it would be just really fun to have a whole show just talking about it and all of the cool things and history and everything. So, um, while I get set up, if you do have any questions for us tonight, leave them down in the comments. Eli is going to be keeping an eye on that for me and will let me know when questions come up. He will either let me know right away or we will have time at the end of the show as well to answer those questions.
Mhm.
So let's get going. We are going to be exploring Mars tonight. And we're going to start way back when in antiquity, because Mars as a planet has been known for honestly thousands of years. One of the reasons for that is it is very bright, so it's a very obvious red point of light in the sky. There's also the fact that it doesn't move like the other, like stars do in the sky, where stars just kind of rise in the east and set in the west. Mars does that. It rises in the east and sets in the west, but it moves across the background of stars day to day. And of course, my headphones are going to start to die. One second. Okay, figures that would happen. Anyway, and that's actually where the term planet comes from. It's Greek for wanderer, because Mars and the other planets wandered back and forth across the background of stars. And then the very red color that is obvious even from here on Earth, looking up at Mars in the sky, really seemed to resonate with many different cultures. And there were a lot of cultures who associated this planet with either war or bad omens or something like that. In fact, the name Mars is the Roman god of war. And we see this in lots of other cultures as well. I know the Babylonians, the Greeks, the Chinese saw it as fire. It represented the fire element to them. So lots of things like that. There was also, I think, I'm forgetting which one, but there was people associated with blood, which is where the whole bad omens came from, and just all of that. You may also be surprised to know that the month of March and the day Tuesday are both named after the planet Mars. March makes a bit of sense. You can see that connection. Tuesday, maybe not so much, but the Latin word for Tuesday is like Martis, which is like when you rearrange and it's basically day of Mars. So that's that connection there. Now moving on a little bit forward in time, a bit has been learned over the centuries about this planet Mars. Back all the way in the 4th century BCE, the great Greek philosopher Aristotle, who is here on the left, was actually able to figure out that Mars was further away from the Earth than the Moon is. And there's actually a really simple way that he was able to determine this, because one night he was watching and Mars disappeared behind the Moon. So obviously that must mean Mars is further away than the Moon is. Then in the center here we have Johannes Kepler, who actually used the orbit of Mars or observations of kind of the path of Mars across the sky that were taken by another astronomer, Tycho Brahe. But he used this data on Mars to figure out that the sun was the center of the solar system, not the Earth, like had been previously thought, and realized that the orbits of the planets are not perfect circles, like had been thought, and the planets don't move at constant speeds. like had been previously thought. So Kepler here used Mars to learn a lot about our solar system and the motions and paths thereof. And then on the very right here, we have my favorite, Mr. Galileo, who I'm including because he was the first to look at Mars through a telescope. So he was the first to get that bit more close-up view. And then we have Christian Huygens here, who was the first to use the telescope to make it says detailed map, which I guess for the time was a detailed map of Mars, but he was the first to attempt to really start to map out the features on Mars that we see through a telescope. And that's going to bring us to an interesting era in our exploration of Mars. So back in 1877, an Italian astronomer, Giovanni Schiaparelli, was studying Mars through a telescope when he thought he saw these like linear features across the surface. And he decided to kind of make a map of this. This is one of the maps that he made. And he ended up calling these linear features canali, which in Italian means channels, which are just natural features that form because of flowing water. Well, the problem is when his work was translated to English, that word canali was mistranslated. And instead of being translated to channels, it was translated as canals. And this may not seem important, but this is actually a very important distinction because channels are natural, canals are man-made. And so this starts this implication that these linear features were made by some intelligent race, and this started the idea that there was life on Mars. This was really kind of perpetuated by Percival Lowell, who ended up building an entire observatory just to study Mars and these canals. And here you can see Lowell next to the telescope in his observatory. So not only did he continue to study this, but he also was responsible for creating lots of maps, books, talks, and he was really the one who got this information to the general public. So that by the early 1900s, it was pretty much considered fact. There was life on Mars, and there was intelligent life, and they had built this system of canals that was at the time interpreted as a way to bring water from the poles to the equatorial regions. And this became so well known that it evaded popular culture as well. We see lots of books and stories that involve these Martians and their canals. So one of the more famous is the John Carter series by Edgar Rice Burroughs. We also, of course, have H.G. Wells's The War of the Worlds. And then another one that I like to include, because it's one that I have read, was by Philip K. Dick, Martian Time Slip. And I included this one because I have it and I started reading it. And it takes place on Mars along these canals with these Martians. And I had to stop and go and look at the publication date to confirm to myself that I was actually reading a story that was written in this time period when we thought that there were these canals and Martians. And it was just a really cool and exciting just find that I found just with a random book that I decided to read. But anyway, moving past that.
Yeah, we got a question.
Yeah.
But really quick, also I need to voice my my appreciation for Philip K. Dick because he also wrote "Do Androids Dream of Electric Sheep?" So
Yes, he did.
he's
I
a
need to
fan
read that
favorite. It's so good. It's so good. Oh my God, we could make a show all about that. We got the question: what excuse me, what magnification were the telescopes they used? Comparable to at home, or were they really big? And are those telescopes still around?
So I know the Lowell Observatory is still functioning. I don't remember how big it is. But the real issue at the time is the quality of the optics, which I'm going to get to in just a second. The actual lenses that were used in these telescopes weren't of high quality, and that led to a lot of distortions, which I'll get to. I actually can get to that right now. So all of this kind of came crashing down back in 1965, when the Mariner 4 spacecraft did the first flyby of Mars and sent back these pictures that show no canals, no Martians, nothing like that. And that's when we realized that something was up. And that's when it was discovered that these canals, these features that were seen, were really partly due to the poor optics in the telescopes at the time, but also partly an optical illusion, because our brains are really good at trying to make patterns that may not actually be there. So combined with the small magnification, the poor optics, and our brain, any sort of random features kind of to people fit together like these lines that were canals. And it's also important at this time to mention that not everyone saw these features when they looked at Mars through a telescope. There was a lot of debate in the astronomical community because some people saw them and some people didn't. And it wasn't until the 1965 flyby that it was confirmed this was an optical illusion, this wasn't actually there. But I think that this was really fundamental in just enticing our interest in Mars, and it hasn't really faded since then. Uh, Even though at this point we realized that there were no Martians or anything like that, I think it still kind of kept Mars at this really special place and kept us really curious and wanting to know more. So that brings us to now Mars as we do know it. So since the Mariner mission, and I'm going to talk more about the kind of early missions to Mars in a minute, we have learned quite a bit about Mars. Here we can see some really good up-close pictures. Mars is a fairly small planet. It's about half the size of the Earth. It is, of course, has the nickname of the red planet for very obvious reasons, that red color there. That red color actually comes from iron oxide, rust, that's on the surface. We can also see that Mars does have polar caps. It has polar ice caps around the north and southern pole. Some of this ice is water ice like ours, but a lot of it is also carbon dioxide ice or dry ice. Mars does have an atmosphere, although it is quite thin. It's only about 1%, the density of Earth's atmosphere, but it is still dense enough that we can see it, like here in pictures. And this atmosphere has not much oxygen. In fact, it is primarily about 95% carbon dioxide. Mars also has two little moons, Phobos and Deimos, which means fear and panic. And they are, as we lovingly call them, lumpy space potatoes. These are likely captured asteroids, since Mars lives on the edge of the asteroid belt. Now, while the atmosphere on Mars is quite thin, it does allow for some interesting weather. So we have evidence of things like dust devils that sweep across the surface. These are some of my favorite videos from Mars. Just these videos of these dust devils. And these tend to be pretty common in the afternoon as the ground and everything is being heated up by the sun, and that hot air, warm air starts to rise. It leads to the creation of these dust devils throughout the afternoon. Mars is also known to have massive dust storms that can sweep the planet. In fact, it fairly often has global dust storms. And here's a great example of one of these that happened back in 2001, where you can really see that dust that gets kicked up into the atmosphere and obscures our view there. All right. So taking another look at kind of a map of Mars, a much higher detail map of Mars than, say, Lowell or Schiaparelli had, we can see that there are a lot of interesting features. Of course, as I mentioned, we have those polar ice caps. We see areas on Mars that have lots of craters. That typically tells us that those are older terrains because those craters have just accumulated over time. And we can see a lot of that is concentrated kind of in the southern portion. But then when we look in the northern portion, things seem a bit smoother. We don't see as many craters, which tells us that this portion of the crust must be relatively younger than the southern portion. And the uh, terrain and geology gets even more interesting when we kind of take a look at the heights of the terrain, the topography. And so this is one of these topographical maps where blue and greens are lower elevation and reds and browns and whites are higher elevation. And we can see a distinct difference in the northern and the southern latitude. So the northern, kind of smoother, younger looking surface also appears to be at a lower elevation, so we call them the northern lowlands, while the southern portion, that is a lot more heavily cratered and therefore a lot older, seems to be at a much higher elevation. And this is a big mystery that we're still trying to solve. We don't quite understand why the two hemispheres are so distinct like this, why there is such a contrast in the elevation between the northern hemisphere and the southern hemisphere. There's a lot of different hypotheses. Some of them involve big impacts that could have carved out this kind of low-lying northern level. There are, I'm trying to think, some evidence of maybe like tectonic activity, but then other evidence shows there is no tectonic activity on Mars. So it's one of the things that we are still trying to figure out and understand, this kind of disparity here. All right. Now, along with this, we can see quite a few features that look like, honestly, they kind of look like little bumps. These are volcanoes that are across the surface of Mars. Mars has quite a few of them, the largest of which is this guy right here, Olympus Mons. So not only is Olympus Mons the largest volcano on Mars, it is the largest volcano in the solar system. This thing is huge, and you can see the comparison here to Mount Everest and some of the other kind of tall mountains on Earth. And the base is also very wide. Like, it would cover up the entire state of Arizona. This thing is massive. And it's so big that, I think, Eli, you mentioned this before, that like if you were climbing up the sides of Olympus Mons, like you wouldn't actually notice the graduation.
It's like the I forget what the grade of it is,
Yeah.
like so little that it almost is imperceivable.
It's crazy. But this is what I was saying. Other evidence of there not being plate tectonics is the sheer size of Olympus Mons and even the other volcanoes on Mars. Because here on Earth, because we have plate tectonics, volcanoes don't sit over the hot spots that's generating all of the energy that leads to the eruptions forever, because the plate moves them off of that hot spot. And then you end up with a new portion of crust over it that starts to erupt, and you get a new volcano forming. And you end up getting these chains, like the Hawaiian Islands. Well, the fact that we don't see that here, and the fact that Olympus Mons is just so big, tells us that it sat over that hotspot for billions of years. So there couldn't have been this sort of plate tectonics motion, or else it wouldn't have gotten this big. So yeah, there's lots here. It's interesting. Anyway, another really cool feature on Mars is right here, also near Olympus Mons. It's this big canyon called Valles Marineris. And this is another quite large feature. You can see here, compared to the size of the United States, this canyon would stretch across the entire country, so definitely bigger than the Grand Canyon, and in fact, in places gets 3 to 4 times deeper than the Grand Canyon. And there is still some debate over exactly what formed this. Canyons, like here on Earth, tend to be formed through combinations of tectonic activity and erosion. And there is some evidence that there might have been some localized kind of plate or crust shifting that could have started this crack. And then erosion led to what we see today. But again, there's still kind of some mystery here in understanding how this feature actually formed. All right. Now, I just mentioned erosion, which leads us to another interesting question of, was there water on Mars? And from a very early time, early in like spacecraft exploration, we were starting to see lots of evidence that this seemed to be the case. So images from spacecraft were revealing things like this, that look like dried up riverbeds. Or features like here or here that look like river deltas. We were seeing features along this northern hemisphere here that look a lot like shorelines. A lot of these dried up riverbed-like features tended to run from higher elevations down to lower elevations into the northern lowland area. And there was just a lot of just features, geological features, that seemed to indicate the presence of liquid water at some point in Mars's past. All right, so let's pause there in our exploration of water and go back to Mariner and kind of our voyage into exploring Mars with spacecraft. So as I said, the very first spacecraft flyby of Mars was by Mariner 4 in July of 1965. This was one of NASA's spacecraft. The Soviet Union did have several attempts prior to this, but they all failed. So NASA had the first successful spacecraft flyby. And then a few years later, in 1971, Mariner 9 was the first spacecraft to go into orbit around another planet. So this was our first success in putting a spacecraft in orbit around Mars. And again, the Soviets had had several attempts before this that hadn't quite worked out yet. But they did get some, we would call it success, in having the first spacecraft to touch the surface. So the Soviets had Mars 2 and Mars 3 landers. Unfortunately, the Mars 2 lander, which landed in 1971, was a rather bad crash landing, so we can't really call that a success. Mars 3, though, in December of 1971, did have a successful soft landing. However, the Soviets lost contact with the lander about 14 seconds after it landed. So it did successfully land, but then for some reason we lost communication with it. And so that brings us back to NASA, who in 1976 launched the Viking program, which had Viking 1 and 2, which both consisted of an orbiter part of the spacecraft, which would stay in orbit around Mars, and a lander that would land on Mars. Both of these did successfully land and lasted for many years. Viking 1 was in service for about 6 Earth years, and Viking 2 was in service for about 3 Earth years. And they gave us the very first color pictures from the surface of Mars. And so here is some other of these pictures. We also found evidence, like you can see here on the right, in the winter times of frost forming on the ground. Thank you, Quinn. So lots of really cool stuff from the Viking missions. And then jumping forward to 1997, we have the very first rover on Mars. This was another NASA program that started with the Pathfinder um, lander that also had Sojourner, which we can see here, which was the little rover. And Sojourner and Pathfinder were in a lot of ways, kind of proof of concept that this could work. That you could have a rover that was capable of navigating obstacles on its own, because there's a lag between us and Mars of anywhere from like 7 to 15 minutes. So we can't like drive these buggies in real time because of the lag there. So they have to be able to navigate obstacles on their own. And Sojourner was NASA's proof of concept that this could be done, and was successfully done, which led to the Mars exploration rovers of Spirit and Opportunity. So here we have Spirit. We can see a nice little panel view of the little Spirit rover. And both of these were expected to last for like 90 Martian days. Yeah, Spirit lasted from 2004 to 2010. And sweet little Oppie here lasted from 2004 to 2018. They were tremendous little rovers that just did the absolute amazing job of exploring Mars for years and years. And I will say, when we lost contact with Oppie in 2018 because of another global dust storm, I got choked up. I was very, very sad when Oppie was declared, I don't want to say dead, but it's kind of the truth. But yeah. But some of the really important work that Spirit and Opportunity did was actually finding mineral evidence that there was once liquid water on Mars. And so, in the big picture, kind of on the right here, is these rocks that have clays within them that only form in the presence of liquid water. And then another thing they found here in the picture on the left are these little spheres of hematite that have been nicknamed blueberries. Um, but it's important because, again, we have a mineral that only forms in the presence of liquid water, and that spherical shape of the hematite tells us that it formed in moving liquid water, things like a river. So this was more than just, hey, that kind of looks like a dried up riverbed, to definitive proof that there had to have been liquid water, or else we wouldn't see these minerals. So Quinn, seriously, they did an amazing job of furthering our understanding of the Mars's past.
So we just got a question. Why did the rovers last so much longer than anticipated?
So I think in part, we give them a kind of smaller time frame as realistic expectations. And then in most cases, spacecraft tend to exceed that, and then they get extended, their mission gets extended. With these on Mars in particular, part of the problem is they were powered by solar power. So they had solar panels. And with all of the dust storms and stuff on Mars, those solar panels are going to get covered in dust. So it was unsure how long they could last before they just lost that solar power. And it turned out to be a lot longer than we expected.
I actually just learned the other day that I believe it was Opportunity. They can tell how much power the things are producing. And so they saw that Opportunity, I think it was at like getting close to like 60% or something like that. And then a dust devil came by and wiped off the solar panel. Yeah, so then it went back up to like 98% power production. I thought that was really interesting.
Yeah, so those ended up being helpful instead of hindering them, it's kind of crazy. But things that, we don't know until we try it. All right, so next up we have the Phoenix lander, which was really crucial because it landed near the North Pole and actually found the direct evidence that there is water ice there. before we knew that there was carbon dioxide ice, but it found that underneath that carbon dioxide ice, there is water ice. It also found that in regions like we're seeing here that don't necessarily look like there's ice on the surface, if you dig just below that surface dirt, you find frozen water there. And so this was our kind of confirmation that there is a lot more water ice underneath the surface than we may have once expected, which is good for any sort of like potential human missions because we need water and it will be a lot cheaper to try and get it there than bringing it with us. Oops. Then in 2012, we had the Curiosity rover that landed, was a brand new type of landing system with this hovering sky crane. It's crazy. And Curiosity has been amazing. It landed at Gale Crater, which was expected or was suspected to be an ancient lake bed. And so along with, of course, cameras and sample collectors, Curiosity has this little laser that can drill these little holes to allow it to analyze samples. And it has indeed confirmed that Gale Crater was once a lake bed. We can see that in the minerals that are there, in the types of rocks, in the geological features. So that has since been confirmed thanks to Curiosity. And then forgot I've added this slide. So with the work of all of these orbiters and landers and rovers, we now are very confident that Mars was once a lot more Earth-like. That back a couple billion years ago, Mars had to have been a lot warmer. There was a lot of liquid water all over the surface. And then something happened to cause it to shift to what we see today, to become the cold, frozen world that we see today. And there's still some exploration into exactly how that happened, why that happened. Part of that's probably just due to the fact that Mars is a small planet. So things like volcanic activity died off a lot sooner than it did here on Earth. But we at least know that Mars was once Earth-like. And one of the reasons we're excited about that is the possibility of life, right? If you have a world like Earth that had Earth-like conditions, that could mean that there was life there. And that is what leads us to the most recent addition to the Mars rover family of Perseverance, nicknamed Percy. She successfully landed back a few days ago on February 18th. She's landed at, and I forgot to look up the name of the crater. I forgot, but it's another suspected lake bed. And in particular, Percy is interested in looking for that evidence of past biological life. So there's lots of Jezero. Yes, that's right.
Jezero.
Thank you. I knew it was a J. So Percy, we're very excited for what she's going to be able to do. She's like Curiosity, but a little bit bigger and better, but more science attached to it, better cameras, things like that, better kind of autonomous driving capabilities. And the other interesting thing is she has with her Ingenuity, which is a little helicopter, which is another kind of proof of concept test to see if we can fly drones. I mean, Mars has an atmosphere, so it might be possible. And that's little Ingenuity, who's been nicknamed Jenny, which I love. We have Percy and Jenny on the red planet, so we have like the start of the little Weasley family there. I love it. So to conclude, I kind of want to just show off a few really awesome things that have come out since Percy landed. My absolute favorite is this video that NASA released of actual video from the landing of the Perseverance rover on Mars. And it's spectacular. So we're going to watch it.
We are starting the straighten up and fly right maneuver. where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Applicant indicates chute deployed.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN safety Bravo.
We have
So
completed our terrain relative navigation.
while we're watching,
Current
actually, hold
speed
on,
is about
just
30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
So freaking cool.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Like, I still am like speechless when I see that video. I've watched that video I don't know how many times at this point.
it really like almost eerily reminds me of the footage from Interstellar where they're like docking. Like something about the camera movement and like the angles that they're at like really reminds me of like Interstellar for some reason.
I haven't seen it
But we
yet.
got a couple things.
Okay.
Oh yeah, you haven't seen Interstellar. Oh, it's so good. Oh my god. So we got, is there a reason Perseverance is a she? I don't know. I don't think any of the other Mars rovers were girls. Maybe it was time
Yeah,
to do.
they're all
We
girls.
got,
Yeah.
oh, they're all girls?
Yeah.
Oh, I did not know that.
Yeah.
And then the other one is, what is the pattern on the parachute? I didn't know about that until now, but I just looked it up. The first, there's two parts to it. The first is
we are starting this straighten up.
it's like code for Dare Mighty Things, which is the Perseverance team like motto. And then the other one is coordinates for JPL, the like where mission control is. Or wait, no, mission control isn't at JPL, is it?
No, JPL is the one in charge of the Perseverance.
Right.
Yeah.
So yeah, so the coordinates for JPL, and then their motto, Dare Mighty Things.
Yeah, which is really cool. I think that was just confirmed like yesterday that's what
Yeah,
that means.
yeah. So like once the footage was released, it was kind of a like a challenge to see who would decode it first, and like internet people got it in 6 hours.
Yeah, I'm not surprised. There. Oh, I also meant to include. There's this really cute picture. You can go find it. That Percy has actually a little like family rover decal sticker on one of its sides,
Oh,
and so it
really?
has the 5 little rovers,
Oh,
including Perseverance, that have been on Mars, and there's also a little like copter by Percy for Ingenuity. It's so
that's cute.
cute. But they're, I mean, NASA is known for having these little like Easter eggs on all of their things.
Yeah. I'm surprised. What's the? Isn't there like a 4chan group of like internet detectives that do this? I wonder if it was them that solved it.
Possibly. I know Reddit was on it pretty soon.
Were they?
Yeah.
Hold on. Reddit.
But Perseverance, while looking for possible evidence of past life, or at least looking for kind of the building blocks of life, has a lot of really cool other things. It's got a weather station. In fact, NASA just released the first audio of winds on Mars. There's a link to that in the video description. It's kind of quiet, so you're going to want to turn up the volume to hear it, but it's so cool. It's also got a system that is going to collect samples and set them aside for a future retrieval mission that is going to retrieve those samples and bring them back to Earth. That mission is still underway, still in development. And then it's also got this other experiment called MOXIE here. That is an experiment to see if we can extract oxygen from the carbon dioxide atmosphere, because if that's the case, then we wouldn't have to bring oxygen with us when humans eventually do go to Mars. So that's another really cool experiment on Perseverance as well. So to give you kind of a layout, this is where a lot of the different landers and rovers have gone on Mars. I really did include way too much in the show. This has gone very long, but it's probably obvious I adore Mars. There's so much cool stuff about it, so much yet to learn, and I'm very excited for Perseverance and what it's going to tell us. So yeah, were there any more questions, Eli?
No, just some like little reactions. Someone saying that your reaction to the landing was priceless. Saying it was very cool to watch. But no,
It's so, I mean,
no other questions.
it's the first, like, we've never had that sort of footage before. That is
Yeah,
unique.
yeah, yeah.
And I didn't
Yeah,
even know that they had that in the works. Like, when they released that, that was like completely like out of left field for me. I had no idea they had those cameras in that video rolling. And in fact, apparently they have a high def version that they just haven't had
yeah.
time to beam to Earth yet.
Mm-hmm.
It's crazy. Anyway, what we are hoping to do with the kickoff of Exploring Mars is actually turn this into a monthly exploration series where we take a topic and we do kind of a deep dive into it. And that's where you guys come in. We want to hear from you. What topics do you want us to explore in this exploration series? And it could be planets, it doesn't have to be. There is a star system, a phenomena, galaxy, anything in the universe. Like, we just want to hear from you. What do you want to know about? And we will start to explore these things in more depth. So
Black holes. I knew it would happen.
I knew, yeah, that's already on the list. We knew that was coming.
I was waiting for it.
We can definitely do that. I think most of us enjoy talking about black holes.
Oh yeah.
All right. Any other questions coming through?
The Northern Lights. Do we have that one written down? I'll write it down.
We've done.
Well, we do have the Aurora, which is pretty much that for the Northern Lights. We'll definitely do it again sometime soon.
Oh yeah.
But if you want to catch it again, go back in the videos tab on the Facebook page, and there will be past recordings of it there.
Yep.
but we'll do it again sometime.
Yeah, it's a pretty popular one, so we'll definitely do it again.
Yeah, that's our highest viewed one by far.
Yeah.
Um,
All right. Well, if you do have any other questions, leave them down in the comments. I'll give that a minute or so, and let me tell you about what's coming up over the next week. So Saturday, we're going to be looking at how we learn about the universe with light, because pretty much everything we know has been figured out through the light that comes through, reflects off of, or something of the object, and there's a lot that we can learn with it. And then next week is the first week of March. So we'll be doing our customary What's Up March edition and March Constellation story time to kick off the new month. So yeah, I think that's it. I think I have gone on long enough. I knew I had a lot. There's a lot to talk about with Mars, and that's not even everything. That's just what I could fit in. But anyway, I guess if there are no more questions, we will wrap it up. So thank you everyone so much for joining us. We do this every week, Wednesdays and Saturdays at 7 p.m. Central, so definitely come back and join us for another show. Again, leave us your exploration show ideas or any other show topics that you'd like for us to cover down in the comments. And yeah, we hope you have a wonderful rest of your evening, and we will see you again next time. Bye, everyone.